Hello, everybody. Welcome to another episode of Analytics Mindset. In this case, we're going to go into basic visualizations with Python and Seaborn, actually one of my favorite topics in programming. Why is it one of my favorite topics in programming? Because you can do so many things plotting in Seaborn. To give some context, there is a lot you can plot if you're not aware in Python and R specifically too. You can do with ggplot, matplotlib, and Seaborn. You can do very powerful visualizations. And the main topic of this conversation is going to be how you can make those visualizations in one go. Let's say Excel, that is by the de facto visualization tool for a lot of people. It has its uses, but you are able to do so much with Seaborn and ggplot that I may cover in the future with so little code and so little understanding actually of how to program in Python. The main difference of this video with the rest of my programming series will be that you actually don't need to know that much about actual programming to coding Seaborn. You can do it by understanding your data. That's going to be very important here. And I am just going to glance over it because I don't want this video to be that long. But more importantly, you can create so many plots with Seaborn, as you will see very soon. Without further ado, we're going to start with Python and Seaborn. For that, we're going to need to import matplotlib, pyplot, and Seaborn. If you don't have these packages, as a reminder, I don't put here my code itself anymore, but you will need to install them. Usually, you will do it by having the install with pip, but I am just not putting that code in my scripts anymore. I'm just letting you know beforehand. We are not going to create our data this time around because Seaborn, the actual package, comes with datasets. There is one dataset called flags that we are going to store in an object called flags data. We have covered datasets before. You can use these. So you're taking the SNS load dataset function that is a function by itself. If you see here, loads dataset allows you to take the flags data from Seaborn and store it in an object. As we have done in the past, we can just go here to Variable Explorer without doing any coding and see that this is data from some flags on years, months, how many passengers they had. That's all you need to know about this data set. It's very straightforward. Now, you can use the head. You can use head to see it's a data frame, a pandas data frame. We can just use head as we have seen in previous videos. If you have not seen my programming series, but we have seen this in the past, where head allows you to get a very quick glance at the columns and the first, in this case, 5 values. I could have made it 10, for example. I'm just going to put it here to show for the sake of showing. Now, a good chunk of visualization is knowing your data. You need to know what you need to plot and how you want to plot it. I have a ton of plots here already. Keep in mind, these plots are because I have spent time working with this data before. But you can do whatever you want to do, actually. Seaborn has a lot of functions, and as you will see, it's a very powerful tool to do stuff with very little code. But we will start with a histogram. If you are more Pythonish than me, you may have different syntax, you may have it put it in an object, you may have it some other place, etc. If you are not familiar with this syntax, pyplot, built on part of matplotlib, has a lot of ways of plotting stuff. There is a lot of different syntaxes, ways you can write your code. I prefer to do it this way because that's how I learned it. With dot flags data, the passengers column, dot plot, dot hist, and 15 bins. What I'm saying here is, in English words, take the flags data, only the passengers. We have seen how to subset a column before. Then use the plot function in matplotlib with the hist argument here and create 15 bins. Now, this is optional, and I can show you if I put this here. I'm going to put this in the console because I don't want to be in the actual code. I'm going to make this to them. You can see how this has only 10 bins and this has 15 bins. There is a small difference, but this has a number of bins. And that's why in the one with 10, we have higher frequencies because the same counts. This is how many flags are there, or records in this case, but it's flags. We know that are spread through how many passengers they had from 100 to 600. We can see there is actually quite a bit of them in the 100 to 200, 250 range. And then there is another spike here from 350 to 400, but then it goes down. Makes sense. Most of these 600-ish, I would assume, are more long distance flights for economic reasons. It's just cheaper for airlines to do that. Now, what's the rest of this stuff? This PLT title is just aesthetics. PyPlot allows you to create a lot of customizations on top of it. You can add a title. This is where the histogram flags by number of passengers comes from. PLT show, I don't actually need it because I'm in Spider, but you may need it if you're in Jupyter Notebook and you don't have this actually. And this window will appear in the output of the code. I'm just leaving it there in case you actually need to put that in your Jupyter Notebook or Jupyter Lab. But these two are just, again, accessory. I could just do this. And again, my plot still, you will see how it says out this because I did not put PLT show, but that's all I need for PyPlot. Now, Seaborn. Seaborn is built on top of PyPlot. Again, if you are more Pythonish than me, if you have some different ways of setting up in Python, if you know how to use the access and all that stuff, that's fine. That's just the way I prefer. I have my way of coding Python. You may have your way. If you're not feel familiar, feel free to explore other kinds of Python syntaxes and how to set up things in Python. That's just my preferred way. Now, Seaborn is built on top of Python. Seaborn allows you to do exactly the same as PyPlot. Actually, that's not fully true. It allows you to do a lot of stuff that PyPlot does, but easier, with an easier syntax. You can do a lot with very little code. That's the main point of Seaborn. And it's actually very focused on creating nice visualizations on the go. If you want to fully customize your diagrams, if you want to really put time in making a very nice custom diagram, you are 9 times out of 10 going to need to use either straight matplotlib pyplot or Seaborn with a lot of pyplot objects. But as you will see soon, if you want to get a histogram, if you want to get a line chart, and you want to just get it in a line of code or two, Seaborn is a very powerful library to do that very easily, very fast. And that's its main feature there. So I'm going to actually do exactly the same I did before. This is exactly the same plot, a histogram, but in this case, I'm using the Seaborn function histplot. And if you see, I'm actually going to run the both of them. So because Seaborn is built on top of matplotlib, it's exactly the same. I can use a set here to say add this title, or I can use PLT title. It doesn't matter. It's exactly the same thing. That's another advantage of Seaborn. Again, it's built on top of matplotlib. You can use a lot of stuff that you use in PyPlot. Just recycle it. If you're familiar with PyPlot, Seaborn is a very nice thing to have on top of it. Now, what's the difference between this and this? Well, as you can see, we have our access label. That's one difference here. Seaborn has some by default arguments. All of these functions in Seaborn have a ton of default arguments behind the scenes that you will need to call by yourself here. In this case, it's only this axis here, the axis label. You see your x-axis as passengers. Here you do not. In more complex plots, though, the difference starts to be noticed. You start to get a lot more things that you will need to code by yourself, declare by yourself, that Seaborn just puts there and says, you go ahead, you do your thing, but I already assume that you want this unless you tell me otherwise. Unless I tell Seaborn that these axis labels are different, Seaborn is going to assume that this is what I want. Matplotlib won't do that. Matplotlib, because it is the default visualization library in Python, will just show me the histogram here and be like, well, I'm doing what you told me. I am uploading a histogram 15 with the flags passenger column. And just to remind you on data frames, you are actually taking first this column, as you can see, subsetting that column. And then you're taking plot, that is probably not going to work. And from there, you are taking the histogram and putting 15 bins. That's what's happening here. It's a more Python-ish way to do things. Seaborn has its own syntax and its own styles that are a little bit different than Python, but again, you can go back and forth with Matplotlib. And personally, I just prefer this style. A lot of coding preferences are up to you. You can recycle a lot of Matplotlib, but we are going to stick with Seaborn for this video. Again, Seaborn is just faster to create stuff on the go for visualizations. You can build everything you do in Seaborn pretty much with Matplotlib. That's really not a secret. You can build all your stuff from the top go and do everything with Matplotlib, but we won't do this today. We will focus on Seaborn and why it's useful. We're going to load the Titanic dataset. It is another dataset that comes with Seaborn. And if you go to Variable Explorer, we can see here really quickly that it has a lot more columns than the flights dataset. It is also way bigger than the flights dataset at 891 records. The reason why we're using this is because it has a lot of different data types and a lot of different variables that we can plot against each other. As a disclaimer, you can filter with Seaborn. I won't show it in this video, maybe in another video where I go more in detail on the visualization side. You can filter in Seaborn. You can filter before you push your data into Seaborn by filtering the dataset, as we have seen before, because Seaborn has a very nice data argument where you can just say, I want you to plot this data. If you filter that data before and you create a new data frame, you will apply your filter by default. We won't go into that right now because I want to show you the power of Seaborn by itself. But data preparation is as big, if not bigger, than data visualization. You need to prepare your data, make sure that you have the correct data, and also understand your data and what you want to visualize. That is one of the hardest parts of visualizing. Seaborn makes it very easy for you to plot stuff. I will actually say it's way less tedious than Excel, in my personal opinion, because you just do a line of code. While in Excel, you need to press 1,000 buttons, and then you need to press them again when you want to redo your plot. While in Seaborn, it's just a line of code that you can recycle over and over again. But that doesn't change the fact that regardless of what tool you use, regardless if it's ggplot, regardless if it's Excel, regardless if it's Seaborn, a very important part that I want you to get from this video is you need to understand your data. You need to understand what you want to plot, because you can just not plot random stuff all over the place and say, I'm done. If you do, your plots are not going to be very useful, I assure you that. That's why you need to understand your data before you plot this, before you put your plot there. And this is where we're going to start with a line plot. A line plot here between the fare, how much passengers paid for their fare in the Titanic, and the age of the passengers. And this might take some time because it's a bigger data set, and also I have a different kind of, but there you go. The reason why it looks like this, I will go by, I have already mentioned, Seaborn assumes things by default. It assumes, it has some default arguments that may not be useful all the times. It has these confidence intervals slash error bars, for example. That's why it took some time to, and it does not start from zero all the cases. So that's why you can see the axis here actually goes a little bit down to accommodate for it, and it's not the true zero axis that here align. But you have a line plot. I am putting the age versus the fare. I am basically saying plot me the age versus the fare of the passengers. You have here the age and you have here the fare. There is actually not really a lot of correlation here. I have done this more for exploratory data analysis. Yeah, see, are all the passengers paying high fares? It doesn't look like that. You can see here, it's very, very jittery, going all over the place. But let's say we want to turn off the confidence interval. You can see here, we can do that really easily with the argument CI. And then we want to add a hue. Basically, you were separating the data in the plot into two. We're labeling that. And here you go. The people that survived most likely had a little bit less of a cheaper fare than the people that did not survive from the same age. That is what you could conclude from this graph. Again, it's not fully the same. Some other kind of plots will be better for this. Now, another very nice part of Seaborn is the axis. We can flip axis pretty easily. I already walked you through most of Seaborn's main default arguments, and again, it will be only line plot. All of these things are just for aesthetic purposes. I want you to pause the video for a second. Try to guess what I need to change here to make the fare go into the other axis and h going to the x-axis. Okay, you should have enough time. For aesthetics purpose, going to change this and call it fare h versus fare. And then what I need to do is putting here x is fare and y is fare and x is h. And as you can see, it's exactly the same as this. But once I execute it, you will see that it doesn't look the same. It's actually the fare here and the edge here. Now, why does it look this bad? It looks this bad because I put some limits on the axis. This is what this does. It puts a limit on the axis. If I flip the axis, I will need to flip these two. So I'm actually going to do that as well. There you go. This line chart is way better than this one, because age has a wider range here, and you can see the fare here as well. It's just cleaner, and it gives you a better understanding than what we had before, where everything was just cluttered on one side of the graph there. Again, there is not really a lot you can assume about it, but see how a lot of people that survive paid higher fares, where you cannot see this a lot here because it's all just cluttered and you could assume otherwise. Now, again, some counts of how many people survived might be better, but you can see how there is some general trend of people paying more fare surviving instead of the people that pay the least for the same age. Not in total, that would be a count. Scatter plots can be also very useful. We are using exactly the same data and exactly the same columns, but instead of doing a line plot, we are just going to do a scatter plot. Here, if the scatter plot doesn't actually make lines between the observations, you can see how a lot of people that did not survive paid a very little fare. You can actually see it here. A lot of people that survived paid a fare. way more expensive fare. You can see here in the 150 to $300 fare, here in the higher end, you can see how there is a lot of people that survive and they paid that bigger fare. You could see that here, yes, but because it was a line chart, you could not see the observations by themselves, at least as easy. Here, you can actually see it way more clearly that there is this bar, regardless of your age, there is this side of the graph where a lot of people did not survive and they paid very little in their fare. Now, was that really a actual concern when the Titanic was sinking? Probably no. When it's sinking, no. But it happened. And that's the magic of plots. You make assumptions, but you are actually testing your assumptions with the data. We are not doing any predictive stuff yet. There is a lot more statistical, a lot more advanced visualizations out there. But for now, I'm just showing you the actual plot and how to do stuff without making any big assumptions on what's happening. You are just plotting the data, you're showing the data as it is. Going further along, you also have outputs. You can layer them on top of each other. So we can take that line plot that we did before, and we can take the scatter plot. So we can actually link the scatter plot between each other here. And you can see how we have the scatter plot actually. We are showing all those points there, and we also have the lines. Now, because I did first the line plot, so that's the first thing that was plotted, and then I did the scatter plot. That was the second thing that was plotted. The points are after the line chart here. Now, I can also rename the axis. This is called X label and Y label. There's other ways again to put the axis labels and change them, but that's how I prefer it. So instead of calling it fare, I'm going to call it passenger fare, and instead of putting it and calling it H, I'm going to call it passenger H, because I just prefer to have them that way. And here you go. From fare and H, now we have passengers fare and passengers H. This allows you to customize a lot of stuff by just adding and working on top of each other. And as you saw it, when I flipped the axis, I needed to change the limits. I will need to do the same for the labels, but it's not a big deal. I can just do it by myself. And if we were looking at more programmatic / automatic stuff, we could just say, take the maximum value of this, take the minimum value of this axis, and then establish that as the limits. That's a conversation for another day. You can use a lot of Python concepts. It's Python at the end of the day. You can use a lot of the concepts. Iteration. You can iterate the graphs too. You can do a lot of those things that we did before with Seaborn and Python. You can incorporate that and use them to create very, very powerful programs in very, very creative ways. But this is just an introduction to Seaborn, and I just want to tell you there is a lot out there that you can do on your own. And hey, maybe you actually come up with another use for Seaborn that I haven't used before. You have a lot of different things in Seaborn, so if you have a stats background, you may have heard about empirical cumulative distribution. Basically, you are plotting in one column how much of each frequency you have, and it goes increasing until it covers the whole data set. Seaborn allows you to do that with the ECDF plot. It's a very handy plotting, and it's in the more statistical and advanced side of things. But as you can see, you just say from the proportion from 0 to 1, where 0 is nothing and 1 is the whole data set. Plot me the age and show me how many people are per age. So let's say by 40% of all passengers were more or less 25 years old, I want to say, to 24 maybe, 25. Or 80% of all passengers were 40 years old or younger. That is how you read this empirical community distribution. Again, you have done this probably in a stats class or another another kind of training where you needed to plot data to see the proportion of how much this is below this thing. If this is exactly the same, it's just plotted. It's a very standard statistical tool to explore data sets, to see data, to do just even in surveys. A lot of times you will hear statements like 60% of our respondents are ages 40 and below or 50 and below. This is this. This is just the graph form of those statements. Half of all the world's population is younger than this age. It's exactly the same. It's the same principle. You take your whole data and then you say all of these are this value or less. All of these meet this criteria of being this value or more. This is just the plot form that in the more formal terms is called the empirical community distribution, also called ECD. And in this case, Seaborn has a build function to do it. You can just do it there, and you just need to say what's your data and what's your X value. Why? Because guess what? The Y value is the proportion. Seaborn comes up with it, and it's not difficult to do it. There is an actual formula that you can go through if you want to, but it's not really rocket science. You just say, count this value in this bin is 1, 2, in this case, age, 3, 4, 5, and then how many of those fall into that proportion, divide that by the total number of observations, that is your proportion. We can apply multiple columns, so we can use this hue argument to take our graph, and this works for all graphs, not only for the ECDF plot, but you can see here how we have the same plot that we had before, but we have 3 different arguments here that are the classes. We have separated it in a hue by first class, second, and third class. What can you notice from here? Well, first class passengers were, in general, a little bit older than other passengers. You can see here how when we're at 50s here, 80% of them were in their 50s. Actually, it's older, my bad. The other way around. They were in their 50s. While for the second class passengers, they were most in their 40s, for 80%. And third class passengers were even younger. So, I mean, pretty common. This was from a century ago, but I think all of us can relate. The older you are, the more time you have to build your money. Usually you get paid more because you have had a longer career and you have had just more time to build your savings. All of those factors. Older people are generally wealthier. Therefore, more people that were older prefer the first class. 30 years old, for example. More or less, let's say 30% of people in the first class were 30 years old. Well, for 30 years old, that skyrockets to 45%. So 45% more or less of the second class was 30 years old or younger. And for the third class, 60% were 30 years old or younger. If you were in the first class, you were just more likely to be older. That makes sense. Again, we are just thinking about each proportion of each category of people that fall under there. But this because there's just not that many young people, honestly, in the first class. You can see how until you hit, let's say, 15 to 16 years, there is just almost nobody in the first class that meets that. I would say probably like, what, 5% or less of people in the first class were younger than 18, while that's way bigger here in the second and third class. I guess you can assume that a lot of kids were in the second and third class. And similarly here, after 60, there were just not really that many people in the three classes too. That is how you read this graph, and that's how you explore your data from these kind of plots. Now, besides these functions, there is also what's called the more generalized function. Cat plot stands for category plot. It allows you to access different kind of plots in Seaborn by using one function. Using one function, and you can do multiple kinds of visualizations in that function. By default, what catplot does is it takes a category, like class, and then it takes age, a continuous variable, and plots them. Here you can see how it's a jitter strip plot. A jitter strip plot basically means you want to see the distribution of how many values you have. It's jittered, so that's why it says jitter there in a strip or something that looks like a strip. That's the default value of Seaborn. Why? Because it's not that very different from a scatter plot. It's just not assuming another axis here, another continuous variable that you are putting a relationship with. But we can make it into a box plot very easily. A box plot in some other visualization tools, it's a little bit more of an advanced tool. It's not really, but you can make that jitter strip into a box plot very easily. This is how you can create box plots in Seaborn. You just take your data, you take your x-axis, you take your optional y, you don't need this y, but we added it because it was here, and the kind of the plot, in this case, a box plot. You have your box, you have your whiskers here, and you can see how the second and third class, second class had a ton of outliers, both younger and older, while the third class had a ton of outliers here in the older section. There were not that many third class passengers that were older. That it's a little bit expected, not a lot, but we saw in our other plot that makes sense. In the second class too, I mean, there were not that many people either that were younger. There were at least a cluster of outliers here, but not enough to cover this. The first class had a ton of young people. You can see that here too. But they were an outlier and they were probably very highly distributed, and they are not outliers because there is a ton of old people too in the first class. The first class is the most balanced one, I will actually argue here, while the second and the third class have skew. The second class is more concentrated in the middle, around the I would say 25 to 35 years, more or less. And the third class is just pushed all the way to this side. Violin plots are another way to visualizing this. They are just, again, I will argue, some people will say it's a more advanced visualization. I argue it's not, but it is for sure a different kind of visualization. You are looking at the same data that you did in the box plot and in the jitter strip plot, but it's a violin that uses smoothing value to show you the same information as the box plot. But instead of having the box and whiskers, you basically say, this is where you have most of your data, and then make it into a ball. If you were to do this with matplotlib, can you do it? Yes, but you will need to declare your own kernel. It's called kernel in this kind of context, and then use smoothing constant. You may need to calculate some values. Seaborn, this is where it excels. It allows you to do this on one go. It's done. You don't need to do anything else. You just need to understand why you use this plot. In this case, you can see there's a huge bulk of passengers around the 20 to 30 years old here in the third class. For the second class, it again is a little bit older, I will say, but the third class has way less people that we saw here in the box plot and in the community distribution in the younger side of things, and is very, very heavily skewed between, I would say, 15 to the 50s part of the plot. It's very, very focused on that specific demographic. And that's not surprising for a lot of reasons we have already mentioned. Now, finally, the last part that makes Seaborn very powerful is something called phase grid. Phase grid basically allows you to take what you have here. We are going to take this actual plot, and we are creating a lot of different plots from that plot. So you can see here how we have for men, women, and everybody else here. We have three actually. I think the third one is child. It's just not showing up there because the title is in our way. There you go. Man, woman, and child. So this is child. You can see how for men there is a lot of them in this fairly uniform distribution. For second and third class, though, in the Titanic, they were heavily focused on this, I would say, prime age working, makes sense? People traveling from England, between England and between the United Kingdom and the US at the time. A lot of them were in the prime age working pretty much the same here in the third class. For women, it's pretty much the same. There is not really a lot of difference. Yes, there is less older women, I argue, in the second class, and maybe the third one, but that's pretty much it. Now, child, obviously, it goes all the way to 20 years old, so that's something else to see there. But you can see how the first class is fairly uniform. The second class is very, very skewed towards, I'll say, 5 years old. And the third class is also fairly skewed, but less so than the second class. But Seaborn allows you to do all of this with just some lines of code, and you just need to know a few arguments. And that is the magic of Seaborn. That is why I wanted to show you how Seaborn works, because you can do a lot with it. And with that, I will finish this video here. I hope this was useful to you. As always, if you find this useful, please leave a comment, leave a like. I appreciate any kind of support. Thank you.